Saxon's Calculus, Lesson 93, is about centroids. Now, a centroid is very similar to the fulcrum point, which we just did on a line, but this is finding kind of like the balance point for an entire shape, not just a line. And so I have given you the formula that you need to find. So it's basically your average, and you're going to do the summation of y times the area dividing by the area. And I realize that that feels a little like it should cancel off, but it's when you're dealing with it in the formula, it's not, because you are ultimately integrating. So now let's jump to example 1, where it said, find the x-coordinate of the centroid of the plane figure bounded by the x-axis, so here, and the graph of y equals the square root of x, which we know is a curve because it's a square root. So it's like 0, and then of course the square root of 4 is 2. But ultimately I didn't need this part because I'm also bounded by the line x equals 2. So we're talking about just this part in here, and we're looking for where that balance or centroid point would be. So we're going to follow here and integrate from 0 to 2, because we're talking about the x-coordinate. So technically I would be saying this, and then we're integrating, and our y is this formula with the square root of x. But we're going to fill it in as its exponent format, which is x to the 1/2, rather than in the square root. And then the area piece would be, where is this falling? Well, it's the distance between the 0 and where it would fall on the x-axis. So that would be an x. And then it's dividing by, I guess I'm going to write it as one big fraction. You can write it as each separate integrations, but I think you get the idea. And then the area that it's talking about on the bottom is the same as this y value, not this area, not this a value. So that's another x to the 1/2. Now again, there's no canceling out. We have to do the integration of each of these individually. So here in the numerator, this becomes a common denominator of 2 over 2. So this is x to the 3/2, and this is x to the 1/2. And when we integrate, this x to the 3/2 goes to plus 2 over 2. So 5/2 flipped to 2/5 x to the 5/2 over, and repeat, add 1, so that's 2 over 2. So 3 over 2 flipped 2/3, and then x to the 3/2. And now we are plugging in for both of those the 0 to 2. So the 0 won't matter on either one of them. Plugging in the 2, okay, I don't want to square root it. So best bet is to punch these onto the calculator, but 2 to the 5th power, then square rooted. Should be 2 sets of 2's. Or 3, hang on. No, 2 sets of 2's pull out. That's 4 times 2, which is 8. There was an extra 2 stuck with it. And then the 5, which I have not dealt with, over, repeating, plugging in the 2. This is only going to be 1 set of 2's pulled out, making it 4 with the extra root 2 over the 3, and a fraction over a fraction should flip and multiply. So 3 over the 4 root 2. Now root 2's can cancel. 4 goes into 8 twice, so 6/5 is all I'm left with. So my answer then is 6/5 is the spot where that should, the x value, where, so like 1 and 1/5 is where that wherever its matching value is where that should fall. Oh, that's a little closer. 1 1/5, something like in there. All right, then in example 2, it says, find the y-coordinate of the centroid of the planar region in the same graph as example 1. So for my integration, where I'm now doing y, average y, I need to figure out what the matching y value is here so I know what my boundaries are. It's definitely going to be 0 at the bottom, but I need to plug in 2 is where the highest it can go. So plugging in 2 here gives me the square root of 2, which they're just going to write that as square root of 2, not put it into a decimal. That would be a little messier here in the integration. So now for the formula part. I know that this part is this unknown distance, which is now the y value multiplying with, and then I need the distance between here and here. So that's a 2. However, here, if I use this line, it's a little different. So it should be 2 minus the x value. And I need to solve for the x value, which would make that squared, so y squared. So this should be 2 minus y squared. Then when I work that out, that's 2y minus y cubed. Oh, and I've not done my bottom part yet, which was the matching 2 minus y squared. So now if I integrate both of those, this becomes 1 plus 1, 2. That kills off the 2, so leaves me y, and then minus 4, so 1/4 y to the 4th over, and this one would go to 2y minus 1/3 y cubed, and I'm plugging in the 0 to square root of 2 for both. All of them have y, so the 0 is irrelevant. When I plug in the root 2 to the 4th power would be 2 twice, so 4 times the 4th is 1. So root 2 minus 1. Wait a second. I don't think I wrote the squared on this one. Let me redo that. Yes, because I went to the 1 and then I failed to write the squared. So when I do square root of 2 here, I get 2. 2 minus the 1 should give me a 1 for the top, and then for the bottom, okay, so 2, I guess I'm just going to write it, 2 root 2 minus, and that's not going to be helpful because that's going to be 3 times, so 2 with the root 2 over top of the 3. Give it a common denominator of 3, that would make it 6. So 6 root 2 minus 2 root 2, 4 root 2 over 3. 4 root 2 over 3. That's at the bottom of a fraction, so to get its actual answer, I should flip it and make it 3 over 4 root 2, which at that point, you just need to plunge into the calc. You can either leave it this way or turn it into decimal, and you should get something very close to 0.53. Now, example 3. Use vertical rectangles to find the y-coordinate of the centroid of the region described in example 3. All right, let me graph this. Actually, I realized I don't really need to graph it. The only piece of information that they give me that's extra is the fact that now, when I'm dealing with this rectangle in here, they're telling me that this is y over 2. So when I do my integration from And this is back to what we did in the original one, 0 to 2. And we still have our x to the 1/2 as we did before, but now it's going to be the y over 2 that we use in here, and it's over top of that same x to the 1/2, just like it was before. So now, what is that y value again? Well, that was x in its form of to the 1/2. So substitute that in. In order to put those together, when I multiply, that's going to be multiply bases, add exponents, so x to the 1/4 over 2 with our x to the 1/2. So then when we integrate the 1/4, that should be 5/4. So 4. Oh, help us all. I said it and I failed to do it. So, okay. They're treating it as a half out here with that denominator, and I'm not. I'm leaving it here. But when I multiply bases, add exponents, and then I multiplied them. A half and a half is a whole. Okay, that feels a little better. So now this x, when I integrate it, becomes squared. So a half x squared is over top of this treating as a half. So if I flip that 2, then that kills this off. And now, we already know what was happening here because we did it before. I'll come back to that one. So then if I'm plugging in 2, 2 squared is giving me 4 over, what was our answer from before? Here, 4 root 2 over 3. Just a second. The 0 part didn't matter. It killed everything off. So it's the 2. Am I losing my half? Okay, just a second. Let me redo this part. X to the first, add the 1, get it to 2, make it a half, right, with the x squared. And it's over the 2 over 1. Wait a second. 2 over 1 flipped 1 over 2. Oh, phooey. This would have been 1/4. Ha ha ha. 2 plugged in, 2 squared is 4. 4 over 4 is 1. Now we're getting there. That is over top of the answer from the last time. 4 root 2 over 3. So again, it flips to the 3 over 4 root 2. Why did they say 3 root 3? Because that's the same as this. Yes, and it should be 0.53. Good grief. Okay. Yeah, and that's the end of lesson 93.